Now the next topic, that is galvanometer as an ammeter. Ammeter, that is the device which measure the current flowing through any branch of the circuit. Okay. Now see, we already discussed this thing in previous theory. Galvanometer that measure the current, that detect the current. Then why we think about the ammeter? Because galvanometer, that is very sensitive device. With the help of galvanometer, you can detect or measure the current which one is very small, of the order of microampere. So here directly we can't use galvanometer as a current measuring device, means ammeter. Why? Some limitations are there. So let's discuss these limitations. Okay. See, suppose we have the circuit as shown in the figure, in which the resistance is connected with the battery having V volt. So if we connect this circuit, then how much current will flow through resistance R? So as per Ohm's law, we know this thing. The current I, which is equal to V by R, that much current will flow through this resistor. And now we want to measure this particular current flowing through the resistance R. Now, any device which can measure the current, where we have to connect it. So we know this thing. In series combination of components, the current through each component will be same one. So if we connect the current measuring device, say galvanometer, directly with the resistance in series. But here what happens, as soon as we connect the galvanometer in series with resistance. Now see here, this is galvanometer. Galvanometer itself have some own resistance. So to understand it, here the resistance of the galvanometer is represented with this galvanometer by Rg. So now the total resistance of the circuit itself is changed. So now current flowing in the circuit, that will be changed one. And now your current, that is I dash equal to V upon R plus Rg. Actually, you want to measure the current I flowing through the resistance R. And as soon as you use galvanometer to measure this current, the current itself in the circuit is changed. This one is one limitation. Second thing, galvanometer is very sensitive device and its current capacity, that is very less. So if slightly large current, then its current capacity pass through it, it will be permanently damaged. So these two limitations are there, due to which we can't use galvanometer as an ammeter. Now what we have to do to convert this galvanometer into ammeter? Up to this one. Now see, if you connect this galvanometer in series with resistance R, then the current in the circuit itself is changed. Now suppose you want to keep this current I dash equal to I, then from this equation mathematically you can understand this thing what to do. If you want to make this I dash equal to I, means simply you can say you have to make Rg equal to 0. If you take Rg equal to 0, then I dash equal to I. But practically it is not possible to make Rg equal to 0, because if you have galvanometer, definitely it will have some resistance. then make it as possible as a small one. Now see, suppose R is very much greater than Rg, then R plus Rg, that will be nearly equal to R. So in that case, I dash, that will be equal to I. It implies that you have to make the resistance of galvanometer that is very small. Now we know this thing. In parallel combination of resistances, the resultant resistance that will be smaller than the smallest one connected in combination. આવું આપણે આગળ ભણી ગયા છીએ. So if you want to make the resistance of the galvanometer very small, then very simple thing, connect very small resistance parallel to the galvanometer. And the small resistance connected parallel to the galvanometer to convert it in ammeter, that is called shunt. That is called shunt. So now the resultant resistance that will be greater than this RS, smaller than this RS. Now see, suppose the circuit current is I. So now when this current reaches at this point A, it will be divided into parts. Now this particular resistance is very small compared to resistance of the galvanometer. So majority current will pass through this one. And through the galvanometer, only the current equal to its current capacity will flow. Suppose here, through the galvanometer current flowing, that is Ig, that is its current capacity, and remaining current flowing through shunt, say it is Is. Now, for this closed loop ABCDA, apply Kirchhoff's second rule. So A to B in the direction of the current, so minus Ig into Rg. Then B to C to D. So here Is, that is D to C, you are moving C to D. So in the opposite direction of current, you can write the potential difference positive. So plus Is Rs, that is equal to 0. So you can write Is Rs, that is equal to Ig Rg. Therefore, Rs equal to Ig upon Is into Rg. But total current was Ig flows through the galvanometer. So this Is, that is I minus Ig. So replace this Is by I minus Ig. So we can write Rs, that is equal to Ig Rg upon I minus Ig. So this is the equation for the shunt, which should be connected parallel to the galvanometer to convert it in ammeter. See how one can use this equation. So see, suppose galvanometer is given to you. For that given galvanometer, suppose its current capacity, that is 1 milliampere. Then its own resistance is suppose 25. So here substitute Ig, that is 1 milliampere, means 10 raised to minus 3 ampere, Rg 25 ohm. Now you want to convert this galvanometer into ammeter, which can measure 10 ampere current. So I, that is 10 ampere, Ig 10 raised to minus 3. Solve this equation, calculate Rs. Then after, connect that much resistance parallel to the galvanometer. Then after, by passing known currents through the galvanometer, recalibrate its scale. Now you can use it as an ammeter, which can measure maximum 10 ampere current. Clear up to this one?